transparent substance. Diamond is colorless, transparent substance having extraordinary brilliance. Brilliance mean what? Brightness, chamak, you can say, right? Diamond is quite heavy. Diamond is extremely hard. It's the hardest natural substance known, diamond, right? Diamond does not conduct electricity. Diamond burn on a strong heating to form carbon dioxide. If we burn diamond in oxygen, the only carbon dioxide gas is formed and nothing is left behind. Nothing is left behind. This shows that diamond is made of carbon only. Carbon dioxide formed by burning diamond can turn lime water milky. Graphite is graphite is grayish, grayish black opaque substance, right? Graphite is lighter than diamond. Graphite is soft and slippery to touch. Graphite conduct electricity. Graphite burn on strong heating to form carbon dioxide. If we burn graphite in oxygen, then only carbon dioxide gas is formed. Which gas is formed? Carbon dioxide. And nothing is left behind. This shows that graphite is made of only carbon. Made of carbon only. The carbon dioxide formed by burning graphite can turn lime water milky. Graphite made of carbon atoms. Its symbol is taken to be C. The two common allotropes of carbon, diamond and graphite, have entirely different physical property. What? Different physical property, right? Physical property. Example, diamond is extremely hard. Diamond is what? Extremely hard, where graphite is soft. Diamond is non-conductor of electricity, where graphite is good conductor of electricity. Example, both diamond as well as graphites form only carbon dioxide on burning in oxygen. Difference in the physical property of diamond and graphite arise because of different arrangement of carbon atom in them. Right? The structure of that diamond. Diamond is crystal. Diamond is crystal made of carbon atom which is powerfully bonded one another by network of covalent bond. Which bond? Covalent bond. The rigid structure of diamond makes it very hard substance. Diamond is non-conductor of electricity. There are no free electrons in diamond crystal. It does not conduct electricity. It does not conduct electricity. A structure of graphite. The structure of graphite is very different from the that of diamond. Graphite is consist layer of carbon atom sheets of carbon atom. Each carbon atom in graphite layer is joined to three other carbon atom by strong covalent bond to form a hexagonal ring. Which types of ring? Hexagonal rings. Various layer of carbon atom in graphite far apart so that no covalent bonds can exist between them, right? Due to sheet-like structure, graphite is the comparatively soft substance. Which substance? Okay. So then, due to presence of free electron in graphite crystal, it's conduct electricity. Just like diamond, graphite has also very, very high melting point. Use of diamond. Diamond are used in cutting instrument like glass cutter, saw for cutting marble, and rock drilling equipment required to diamond. Diamond is harder than glass. You can think diamond is harder than glass. The tips of this glass cutter is made of synthetic diamond. Glass cutter is made of synthetic diamond, which is not good enough for making jewelry. Which is not good enough for making jewelry. Diamond are used for making jewelry. These bracelets contain many small diamond. Here is bracelet. This bracelet contain many jewelry. A sharp diamond edged knife, keratom, used to eye surgeons to remove the cataracts from the eye, which things is removed from eye cataracts. Sharp edged diamonds used for eye surgeons to or as a tools remove the cataract's eye with great precision. Diamond can also made artificially, right? Diamond can be made artificially by subjecting pure carbon to very high pressure and temperature. This is called synthetic diamond. Synthetic diamond are small but high pressure and temperature. But high pressure and temperature. The diamond which are not suitable for making jewelry, right? Are used glass cutter, diamond astute, saw, and drill bits. Uses of graphites. Due to softness, powder graphite is used to lubricant, right? For the fast moving parts of machinery, it can used for lubricating those machines parts which operate at very high temperature, right? Graphite is good conductor of electricity. Which graphite is used for making carbon electrodes or graphite electrodes in dry cell and and electric arc. Carbon brushes of electric motor are also made of graphite. Graphite is used for making the core of pencil core, pencil leads, pencil pens, black pens. These are made by the graphite. Buckminster fullerenes. Buckminster fullerenes is allotropes of carbon containing cluster of 60 carbon atoms joined together to form a spherical molecules. You know, there are 60 carbon atom in molecules of Buckminster fullerenes. So its formula is C60. C60. Buckminster fullerenes is the football shaped sphere. Which types of football shaped sphere? Spherical, in which 60 carbon atoms arrange in interlocking hexagonal and pentagonal rings of carbon atom. There are 20 hexagons and 12 pentagons of carbon atom in one molecules. Buckminster fullerenes. This allotropes was named Buckminster fullerenes after the American architect Buckminster Fuller because its structure resembled the framework dome-shaped dome-shaped hall design by the Fuller larger international exhibitions. The arrangement of carbon atom in Buckminster Fullerenes resemble a football. The structure of the Buckminster Fullerenes is similar to football, made of the hexagonal and pentagonal panel, like same corner of panel representing the carbon atom. Carbon made of 20 hexagonal and 12 pentagonal panels, and the corner of every panel representing a carbon atom. Buckminster Fullerenes is dark solid room temperature. Dark solid room temperature. It's differ from other two allotropes of carbon, diamond and graphite. What? Diamond and graphite. Diamond and graphite. In fact, diamond and graphite are giant molecules which consist of the unending network of carbon atom. But Buckminster Fullerenes is very small molecules made up only 60 carbon atom. How many? 60 carbon atom. Just like diamond and graphite, Buckminster Fullerenes also burn on heating to form a carbon dioxide. If we burn Buckminster Fullerenes in oxygen, then only carbon dioxide is formed and nothing is left behind. This so that the Buckminster Fullerenes is made of carbon only. What? Carbon only. An important physical property in which the three allotropes of carbon differ their hardness. Diamond is extremely hard, whereas graphite is soft, and other hand, Buckminster Fullerenes is neither very hot nor very soft. Other property of the Buckminster Fullerenes are still being investigated. Right? Organic compounds. What is the organic compounds? The compound of carbon is known as organic compound. The compound of carbon are known as organic compound. Apart from carbon, most of the organic compound contain hydrogen, and many organic compounds contain oxygen or other elements. So most of the organic compound are hydrocarbon containing only carbon and hydrogen. Other derivatives, some of the example of organic compounds are methane CH4, ethane C2H6, ethane C2H4, ethine C2H2, trichloromethane CHCl3, ethanol C2H5OH, ethanol CH3CHO, ethanoic acid CH3COOH, and urea CONH2. Carbon compounds are covalent compound having low melting points and boiling point. Methane melting point is minus 182. What? Yeah, 100 minus 182 degrees Celsius. Boiling point minus 161 degrees Celsius. It is a gas. Trichloromethane, you can say it's chloroform also. When you will just put in front your nose, you will be out of conscious. So this is in previous time that things is used for unconscious someone. Yeah. Minus 63 degrees Celsius is melting point, and boiling point is what? Boiling point is the 61 degree Celsius, right? And ethyl alcohol. You know, ethyl alcohol is used for manufacturing what? Alcohol, wine. That way use these things. Methyl alcohol is the not used for it. Ethyl alcohol minus 114 degrees Celsius. It's a melting point, and when I will talk about boiling point, 78 degrees Celsius is the boiling point. It is a liquid. What? Liquid. It's a physical state at the room temperature is liquid. Ethanoic acid, acetic acid is the same. Its melting point is the 17 degree Celsius and boiling point is 118 degree Celsius. Right? It's a liquid. Right? The low melting point and boiling point of above carbon compound show that the force of the attraction between their molecules are not very strong. So they are covalent compound. Most of carbon compound are non-conductor of electricity. Most of carbon compound is non-conductor of electricity. It's also so the carbon compounds are covalent in nature. They not contain ions. They do not contain ions. Organic compound occur in all living things like plant and animal. Initially, all organic compounds were extracted from natural material, obtained from living things. It was therefore thought the organic compound could only form within the living body. Hence, vital force which creates living things was necessary for their preparation. This vital force theory organic compounds was disproved by the scientist Frederick Wohler. Frederick Wohler in 1828. When? 1828. Right? Wohler compounds. Wohler prepared the organic compounds. Urea. Urea is used in your field also. So CONH2 is the formula of the urea in the laboratory from the inorganic compounds ammonium cyanide NH4CNO lead to rejection of the vital force theory of the synthesis of organic compound. Thus, oxide of the carbon. What? Like carbon monoxide and carbon dioxides, carbonates, hydrogen carbonates and the carbides also carbon compounds, but they are not considered to be organic compounds. The study of carbon compounds is called organic chemistry. The study of carbon compound is called study of the study of carbon compound is called organic chemistry. What? Oxide of carbon, carbonates, hydrogen carbonates, carbides, inorganic compounds which are studied in organic chemistry. In organic chemistry. Understood? The large number of organic compounds, yeah, carbon compounds, number of carbon compounds are already known, they present more than 5 million. How many million? 5 million. Many more new carbon compounds are being isolated, yeah, prepared in laboratory every day. In fact, the number of the carbon compounds alone is much more than number of the compounds, other elements taken together. We will now discuss reason to extremely large number of carbon compounds. Yeah, organic carbon compound you can say as well as organic compound. Reason for large number of organic compounds or carbon compound. Two characteristics property of carbon elements which lead to the formation of very large number of organic compounds. First, catenation, self-linking. Catenation, self-linking, right? Another is the tetravalency, four valency. One reason for the existence of large number of organic compounds, carbon compounds, that carbon atom can links with one another by means of covalent bonds to form long chain of carbon atom, right? The property of carbon element due to which atom can join with one another, which is the responsible for very large number of organic compound, right? Catenation means the self linking. When carbon atom combine with one another, three types of chain can be formed. These are straight chain, branched chain, closed chain, a ring type chain, you can say this also. Understood? Six carbon atom are the same straight chain. Five carbon atom are the straight chain, but the sixth carbon atom is the form of branch. So it's called branch chain. Which chain?
Branch change.
Branch chain. Another reasons for the existence of the large number of organic compound or carbon compounds is called that the valency of carbon is 4, which is quite large. Due to large valency of 4, carbon atom can form covalent bonds with the number of carbon atom as well as with the large number of other atoms such as the hydrogen, oxygen, nitrogen, sulfur, chlorine and many more atoms. This lead to the formation of large number of organic compound. Types of organic compound. First you can say the hydrocarbon. Second you can haloalkanes. Yeah, halogenated hydrocarbon you can say also. Alcohols, aldehydes, ketones, carboxylic acid. Yeah, organic acid you can say also this. These are six compounds. Hydrocarbons. What do you mean by hydrocarbon? A compound made of hydrogen and carbon only. This is called hydrocarbon. Which compound is made of
Carbon only.
hydrogen and carbon only is called hydrocarbon. Hydrogen plus carbon is equal to
Hydrocarbon.
hydrocarbon. Methane is the example of the hydrocarbon. Ethane is also, ethene is also, ethine is also. All are the hydrocarbons because they are made of only two elements, carbon and hydrogen. Most of important natural source of hydrocarbon is petroleum. What?
Petroleum.
Petroleum, which is called crude oil also, which obtained from the underground oil deposit by drilling oil well. Natural gas which occur above the petroleum deposit also contain hydrocarbon. Types of hydrocarbon. Hydrocarbon are two types. How many types? Saturated hydrocarbon, unsaturated hydrocarbon. Saturated hydrocarbon in which the carbon atom are connected by only single bond is called saturated hydrocarbon. Saturated hydrocarbon also called alkanes. What?
Alkanes.
Alkanes. We can now say that an alkane is a hydrocarbon in which the carbon atom are connected by only single covalent bond. Which covalent bond? Single covalent. There is no double or triple bond in alkane. Alkane have only one bond. So it's called alkane. No double and triple bond it have. Understood?
Yes, sir.
Hydrocarbon, methane, ethane, propane, butane, a series of compounds known as the alkanes. Name all this saturated hydrocarbon. End with ANE. ANE. You will remember this point in your mind. Methane, ANE, ethane, propane, butane. तो CH4, C2, S6, C3, H5, C4, H10, butane are all the saturated hydrocarbon which contain only carbon single bond, right? Single bond. You can see here. Structural formula saturated hydrocarbon. The general formula of saturated hydrocarbons or alkane is CnH2n plus 2, where n is the number of carbon atom in one molecules of the alkane. If an alkane has one carbon atom, the molecules, then n is equal to 1. Molecular formula is the C1H2 into 1 plus 2, CH4, C2S6. Again, you can write methane, CH4, ethane, C2S6, propane, C3SH8, butane, C4H10, and pentane, C5H12. Right? Saturated hydrocarbon are chemically not very reactive. They are quite unreactive. Unsaturated hydrocarbon. Alkene या alkyne. Alkene या alkyne. A hydrocarbon in which the two carbon atoms are connected by double bond. Which bond? Double bond, triple bond is called unsaturated hydrocarbon. Ethane. What is this? Ethane. Ethane. Right. Ethane, you can say this. Hydrocarbon in which two carbon atoms are connected by the double bonds or triple bonds is called unsaturated hydrocarbon. Ethane, H2C, double bond CH2, and the ethyne HC, triple bond CH, are two important unsaturated hydrocarbon because ethane contain double bonds and the ethyne contain triple bond between two carbon atom. Double bond is formed by the sharing of two pair of electrons between the two carbon atoms, where the triple bonds is formed by the sharing of the three electrons between the two carbon atom, where the triple bond pairs between two carbon atom. Saturated hydrocarbon are obtained mostly from petroleum by the pairs of process is called cracking. Unsaturated hydrocarbon are obtained mostly from petroleum by process of cracking. Unsaturated hydrocarbon are two types: those containing carbon double bonds, alkenes, and those containing carbon triple bonds, alkynes. Let's alkenes alkenes an unsaturated hydrocarbon in which two carbon atoms are connected by the double bond is called alkene. What? Alkene. What? Alkene. Alkene contain C double bond C, H2C double bond CH2, ethene, propane CH3 bond single bond CH double bond CH2, propane. Two alkanes because they contain double bonds between the two carbon atom. An alkane has double bonds between two carbon atom. It's obvious. Simplest alkene will have two carbon atom in its molecules. In its molecules. No alkene having only one carbon atom, right?